That B.Sc Physical Chemistry, that is Unit 11, Distribution Law. So, in this unit, main objectives of the unit is to learn about the distribution law and Nernst distribution law, where application of their Nernst distribution law and some examples for the distribution law and also Henry's law with a form of distribution law. So main determination of equilibrium constants from the distribution law. These are the objectives of this unit. So while you are going to study, the main topics which we need to study is define the distribution law, explain the Nernst distribution law, and verify the distribution law taking water and carbon tetrachloride. So these are the applications. What are the applications of distribution law? We are going to study and identify the change in molecular state of a solute, and also the solute undergoing association or dissociation, whether the solute is attaining association or dissociation constant, that we are going to study in this unit. So before getting into the topic, we should be knowing what is distribution law. Distribution law refers to the distribution of substance between two different phases. So it is the distribution between two different phases. It may be solid, liquid, or liquid gas. So different phases. One phase is solid, another phase may be the liquid, or one phase may be solid, another phase may be the gas. So how the molecules are distributed between two different phases, that we are going to study here. Mute ಮಾಡಿ. So this is with respect to distribution law. Distribution law refers to the distribution of substance between two different phases, such as solid liquid, or liquid gas, or solid gas. The distribution law is described by the partition coefficient. It is described by partition coefficient, where the ratio of concentration of substance in one phase, the concentration of the same substance in the other phase. So the concentration of the substance will be of same. For example, the substance have high partition coefficient, means tends to be more concentrated in one phase than in another phase. So the distribution law is also important in pharmacology, as it can affect the absorption, distribution, metabolism, and excretion. So these are the ADME properties of the drug. ADME ಅಂದ್ರೆ absorption, distribution, metabolism, and excretion. So these are the properties which are important in the preparation or synthesis of a drug. Drug synthesis and how it is going to be acted inside the body. Body will getting react ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ you are going to study by using absorption, distribution, metabolism, and excretion. What are the percentage of drugs that can be seen in ಎಷ್ಟು percent absorption ಆಗುತ್ತೆ, distribution bodily how much the percentage of drug will be distributed, and further it metabolism ಗೆ ಎಷ್ಟು help ಮಾಡುತ್ತೆ, and remaining part of the drug what it can be, it comes in the excretion. So these are the method for the distribution of a drug that we are going to study in the distribution law. And coming to the Nernst distribution law, Nernst distribution is the statistical law that describes the distribution of ions in a solution at equilibrium. So it studies the distribution of an ions of a solution in the equilibrium state. Uh, Here, it states that the concentration of an ion in solution will be directly proportional to the activity of the solution, which is the measure of ion's ability to participate in the chemical reaction. So, the concentration of an ion in the solution will be directly proportional to the activity. So, the concentration of the given solute or an ion in the solution, which is a measure of ions ability to participate in the chemical reaction, the concentration of ions present in the given solute. The Turner distribution law can be used to predict the distribution of ions in solution. So, Nernst distribution law can be used to predict ions in the given solution based on the chemical potential, which is measured on the energy required to transfer ion from one phase to another phase. So it is the measure of energy, the energy which is required to transfer from one phase to another phase. Phase andre from solid to liquid, liquid to gas. So energy is needed to transfer from one phase to another phase. That is the Nernst distribution law. Here, ion is equal to K star into ion standard, where ion is the concentration of ion in the solution. So, number of concentration of ion in the solution. K is the equilibrium constant. Ion is the standard. That is the standard concentration of the ion. Now, we are going to calculate the Nernst distribution law. So, coming to the first topic here, distribution law. So, in distribution law, ಅಂದ್ರೆ so it law refers to the distribution of chemical substances between two phases such as solid liquid or liquid gas and a gas phase. So the distribution law is described by partition coefficient, which is the ratio of the concentration of the substance in one phase and also in the concentration of the partition coefficient. So here for example, what how the distribution law works here andre, if you take two immiscible solvent, that is solvent A and solvent B. So there will be two different layers will be formed when X is the solute which is soluble in both the solvent is added. So this is the experimental part. We have taken two solvents A and B in a single beaker and we are going to add X moles of solute to that beaker. For example, X we can take it as acid and solvent A can be taken as ether and solvent B can be taken as water. ಈಗ ಟೂ ಡಿಫ್ರೆಂಟ್ ಸಾಲ್ವೆಂಟ್ಸ್ ತಗೊಂಡಿದ್ದೀವಿ ಫಾರ್ ದಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಆ್ಯಡ್ ಅಂದರೆ ಇಮಿಸಿಬಲ್ ಸಾಲ್ವೆಂಟ್ ದಟ್ ವೋಂಟ್ ಬಿ ಸಾಲ್ಯುಬಲ್ ಸಪ್ರೇಟ್ ಲೇಯರ್ ಫಾರ್ಮ್ ಆಗಿರುತ್ತೆ ಸೊ ಫಾರ್ ದಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಆ್ಯಡ್ ಎಕ್ಸ್ ಮೋಲ್ಸ್ ಆಫ್ ಸಲ್ಯೂಟ್ ಅಂದರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ವಿ ಆರ್ ಟೇಕಿಂಗ್ ಎಕ್ಸ್ ಆಸ್ ಎನ್ ಆಸಿಡ್ ಸಲ್ಯೂಟ್ ಎಕ್ಸ್ ಏನು ತಗೊಂತೀವಿ ಎಕ್ಸ್ ಮೋಲ್ಸ್ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದರೆ ಬಿಕರ್ಗೆ ಆಸಿಡ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಆ್ಯಡ್ ಸೊ ಹೌ ದ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ವಿಲ್ ಬಿ ಟೇಕಿಂಗ್ ಬಿಟ್ವೀನ್ two different phases, that is solvent A and solvent B, we are going to calculate the X moles in the solute X which is soluble in both the solvent is added. It gets distributed between the two layers, that is solvent A and solvent B. So molecules of X passes from solvent A to B, from B to A. Finally, the dynamic equilibrium will be set. The equilibrium baratala after certain time, some molecules will be solved mean with solvent A and some molecules of X, that is acid, dissolved in solvent B. So after certain time, it will come to the dynamic equilibrium. So at equilibrium, the rate at which molecules of X passes from one solvent to another is balanced. After attaining the equilibrium, the rate at which molecules of X passes from one solvent to the other is balanced. So when it is balanced, ಅಂದ್ರೆ solvent A in the solvent B ಗೆ solvent B in the solvent A ಗೆ X moles molecule, that is solute X share ಆಗ್ತಾ ಇರುತ್ತಲ್ಲ, after certain time it will come to the balance, means it will come to the equilibrium state. So that we are going to calculate the constant. How you are going to calculate ಅಂದ್ರೆ the here it is the equation concentration of ಏನು X in A means concentration of ಎಷ್ಟು solute acid ಎಷ್ಟು add ಮಾಡಿರ್ತೀರಾ, that we are going to take it here. See, for example, solute X we are going to add in the solvent A, B, beaker ಗೆ. So the concentration of X ಎಷ್ಟು concentration ಇದೆ in solvent A portion, and the concentration of X in solvent B divided by solvent B, that is the constant, that is the equation given here. Concentration of X in a solvent B A divided by concentration of X in solvent B is equal to constant. For here they are taken example, ಯಾವ್ದು example ತಗೋಬಹುದು ಅಂದ್ರೆ they are taken X ಅಲ್ಲಿ succinic acid between ether and water. So X may be given as succinic acid, and ether solvent A can be taken as ether, and solvent B that can be taken as water. So ether and water will not be mixed, and finally you are going to add X moles andre succinic acid you are going to add to the beaker. So whatever the soluble concentration, that is with respect to solvent A ether and solvent B water, we can see the changes, and attaining the equilibrium state we are going to determine is concentration of solvent A and solvent B. It may be varied because adding of X moles of succinic acid. So that they are given the tabular column here, concentration of acid in ether. So these are the concentration present after adding of succinic acid, the concentration of acid in water. So after adding of ಏನು ಆ್ಯಡ್ ಮಾಡಿದಾಗ ಸುಸೆನಿಕ್ ಆಸಿಡ್ ಆ್ಯಡ್ ಮಾಡಿದಾಗ, ಸೊ ದಿಸ್ ಇಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಡಿವೈಡ್ ಮಾಡಿದಾಗ ದಿಸ್ ಈಕ್ವೇಶನ್ ವಾಟ್ ವಿ ಆರ್ ಟೇಕನ್ ಜನರಲ್ ಈಕ್ವೇಶನ್ ಇಯರ್, the concentration of X in A is the general equation what we have taken. The concentration of X in A divided by concentration of X in B is equal to constant. We are going to calculate for this also andre same thing that you are going to same equation, concentration of X in A divided by concentration of X in B, C1 by C2 ಮಾಡಿದಾಗ you will get the constant. So this is what we are going to calculate the distribution law. And further the explanation of distribution law andre the solute X reaches dynamic equilibrium, means when X moles add ಮಾಡಿದಾಗ it reaches to dynamic equilibrium, the rate of R1 at which molecules of X passes from solvent A to solvent B. X moles solvent A ಇಂದ solvent B ಗೆ pass ಆದಾಗ proportional concentration will be there, that is C1. C1 is represented as concentration of solvent A, C2 is represented as concentration of solvent B here. The rate of migration of solute from one solvent to other is equal. It will be equally distributed alla when you are going to add acid or whatever it may be. Two immiscible solvents ke when you add in solute, they will be equally distributed between two solvents. So that we are going to see in this experimental part. At equilibrium, the number of molecules of passing from solvent into proportional to this concentration in A and vice versa. Also, the rate of migration of solute molecules from A to B can be seen here. That is the C1 by C2 is equal to S1 by S2. That is K is the constant and D is the distribution. Equally distributed anta when you are going to add in the two different immeasurable solvents. So next topic is Nernst distribution law. Here, a solute distributes itself between two non-miscible solvent interaction with each other. Non-miscible solvent ಎರಡು mix ಆಗಲ್ಲ. So that solvent interaction with each other, such as the ratio of its concentration in the solvent is always constant at constant temperature. Here, with respect to temperature, also it varies. When the temperature is increased, the miscible two different miscible solvents also get mixed up. So that will be with respect to temperature also. So here, a solute distribute itself between two non-miscible solvent interaction with each other in such a the ratio of its concentration in the solvent is always constant at constant temperature. So if C1 is the concentration of solute in one liquid and C2 is the concentration of the solute in solvent B. So C1 by C2 is equal to Kd. That is the constant distribution. Kd is the distribution coefficient partition. So even the concentration will be constant when it is added. And solubility and distribution law where C1 and C2, C1 by C2 is equal to S1 by S2. S1 and S2 are the solubility of solute in two solvents. So how much the soluble? Here it's nothing but the concept is different. Same. Other distribution law and Nernst distribution law, two different solvents you are going to take and it won't mix up. That is the two non-miscible solvent. Miscible alla. Non-miscible solvents you are going to take it in a beaker. Two different layers irutte solvent. So ether and water, benzene and water. So different solvents you are going to take and add one acid to that. So that acid ಎಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸಾಲ್ವೆಂಟ್ ಎ ಜೊತೆ ಮಿಕ್ಸ್ ಆಗುತ್ತೆ ಎಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸಾಲ್ವೆಂಟ್ ಬಿ ಜೊತೆ ಮಿಕ್ಸ್ ಆಗುತ್ತೆ that we are going to identify. That is the distribution coefficient. How much it is distributed between solvent A layer and solvent B layer. So that concentration we are going to identify to determine its distribution between two different layers. That is known as distribution law, where Kd is the distribution coefficient, partition coefficient. And next is the solubility and distribution law andre, that is one C1 by C2 is equal to S1 by S2 is equal to Kd. That is the distribution coefficient. And S1 and S2 are solubility of the solutes in the two different solvents. So verification of distribution law taking water and carbon tetrachloride. Here we are taken one more example, that is water and carbon tetrachloride. So the concentration of first layer, that is C1 carbon tetrachloride ತಗೊಂಡಿದ್ದೀವಿ and C2 layer is water. Different concentration add ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? Iodine. Here X moles anta iruttalla, X we have taken as iodine. So when you are going to add iodine, there will be different concentration here 5.1, 0.06 different ratio dalli soluble agide. So that we are going to identify its distribution. How much it is distributed between two different layers or two different solvents. So that here Kd is equal to distribution coefficient, that is 85 by one at 25 degrees Celsius. 25 degree andre it will be in the room temperature. The ratio of distribution of iodine between these two liquids, that is carbon tetrachloride and water with each other is 85 is one ratio. 85% in the ಕಾರ್ಬನ್ ಟೆಟ್ರಾಕ್ಲೋರೈಡ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆದರೆ ಒನ್ ರೇಷಿಯೋದಲ್ಲಿ ವಾಟರ್ ಜೊತೆ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿದೆ. ಸೊ 1%. ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಇಯರ್ ಗಿವನ್ ಇಯರ್. The partition coefficient is equal to concentration of iodine in. We are going to calculate the partition coefficient ಅಂದ್ರೆ here partition coefficient, the concentration of iodine in carbon tetrachloride divided by concentration of iodine in water. So how much it is dissolved in carbon tetrachloride and in water, that we are going to calculate the partition coefficient, how much it is distributed between two different solvents. And limitations of distribution law. Next, the temperature is kept constant throughout the experiment. If the temperature is varied, the concentration also it may vary, and even the concentration of solvent A and solvent B will be varied. So the temperature should be kept constant, and solute should not chemically react with any of the two solvent. The solute what you are going to add, for example, as acid on that we next in the another experiment we added in iodine we have added. So that should not react chemically with any of two different solvents what we have taken, carbon tetrachloride, water, ether. So ಅದ್ರ ಜೊತೆ it should not chemically react. It should distribute between these two. The concentration of the solute are noted after equilibrium has been established. So the molecular state of solute is the same in two solvents also. The molecular state of solute it's also same in the two solvent. And also the concentration of solute added should be low. The concentration of solute what we are going to add it should be low, and the concentration is high, the distribution law doesn't holds good. Concentration of the solute what you are going to add, for example iodine clay, one more acid, the whatever the concentration you are adding as an X should be very less. And application of Nernst distribution law in the process of separation and purification organic compound during the preparation using ether solvent. So purification of organic compounds, we are going to use ether as the solvent. So it dissolve the organic compound and it can be separated easily with other mixtures, another residues in that. It can be separated and purified. And in the recovery of silver from Argentiferous head by Parkes process. This method is used and to find the association or dissociation of solute of any of solvent. It can be this another distribution law can be used to find the chemical reactivity of solute with any of the solvent. Chemical reactivity can be identified by any of the solvent to find the effective temperature of distribution of solute. So with respect to temperature, it can be identified to confirm bromine iodine is qualitative analysis can be used. So distribution law modified by change in molecular state of the solute. So when the molecular state of the solute is changed, the distribution law also little modified. According to another distribution law, C1 by C2 is constant. So concentration of one solute divided by concentration of another solute will be always constant. So only if solute exerts a simple molecular into solvent. If the solute undergoes association or dissociation, if the solute undergoes association or dissociation. One of the solvent. It is found C1, C2 is not in constant. So association or dissociation adaga the it not be in the equilibrium state ala. So it is found C1 and C2 is not in the constant. In such cases, distribution law applies only to the part of the solute which is present in simple as molecules. Only to the part of the solute it can be identified. So for that association ಆದಾಗ ಏನಾಗುತ್ತೆ dissociation ಆದಾಗ solute what it undergoes it can be seen in this experimental part. The solute undergoing association. So the solute is present as simple molecule in A and N molecules of X associate to form XN. So in solvent B, assuming that few molecules of X are also present in solvent. So in solvent A, this is the solvent A, this is the solvent B. Few molecules of in solvent B, few molecules of X are also present in the solvent. So X present in the Lile. When X is added to the, it should be equally distributed, means equally agrala. So some association it's going to take place under more concentration of X is present in the solvent B. So how it can be calculated andre let C1 be the concentration of X in A and C3 be the concentration of X in B and C2 be the concentration of Xn. That is the after equilibrium, that is the Xn in B. So here C1 by C2 is the KD, that is the coefficient, standard coefficient, constant. And applying distribution law here, X is the solvent and X in solvent B. Applying law of mass action, Nx is equal to Xn, that is the reaction taking place inside the solvent B. Xn by x to the power of n divided by Xn or Kc, that is the coefficient constant, or C3 n by C2, that is the Kc, partition coefficient. Kc is nothing but the partition coefficient. Taking nth root on both the side, where it can be n C3 divided by n root of C2 is equal to Kc root of n. That is the equation 3. Dividing equation 3 1 by 3. We get it the equation. That is the association occurs in solvent. So this is the method for solute undergoing association. When the solute undergoes dissociation, separate ಆಗ್ಬೇಕಾರೆ dissociate ಆಗ್ಬೇಕಾರೆ when X present in small molecules of A and it dissociate into A plus B giving solvent B. So when X is added, it dissociates to give A in there will be no change in the solvent A. In solvent B ಏನಾಗುತ್ತೆ X dissociate ಆಗುತ್ತೆ A plus B it gives. So for that let A C1 that is the concentration of A be the concentration of X in A and C2 be the concentration of X present in the solvent B. Solvent B list the concentration of X in the dissociation undergoes. That is the B concentration present in the B solvent. So X is equal to A plus B. X is equal to 1 minus alpha A plus alpha. Here, applying the distribution law to the normal molecules in two solvent. Distribution law we are going to apply ಅಂದ್ರೆ C1 by C2. C1 is the concentration of solute A and C2 will be the concentration of solute B. When further Henry's law. Henry's law ಏನಾಗುತ್ತೆ? State that at constant temperature, solubility of gas in liquid is proportional to the pressure of gas above it. So when the temperature of the solubility of gas in a liquid is proportional, the pressure of the gas is above. English expressed in mathematical way andre, where C is the solubility or concentration. That is what C1, C2 under concentration. Soluble ಎಷ್ಟಾಗಿರುತ್ತೆ of X molecules, K is the constant and P is the pressure of the gas here. For the Henry's law mainly used for liquid and gas. For example, we are taking here carbonated beverages. Carbonated beverages ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? When you are adding carbon dioxide in water, so those are known as carbonated beverages. Soft drinks ಅದರಲ್ಲಿ water plus gas ತಾನೆ, carbon dioxide ತಾನೆ. So when it is shaked, it is equally distributed in bottle, the gas and water. When it is opened, the gas, it will come to the open space ಅಲ್ಲ, that is the experiment here. The phase A, that is liquid settles down. Bottle ಅಲ್ಲೇ settle ಆಗುತ್ತೆ liquid. Bottle open ಮಾಡಿದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ? Gas will come out. That is the example for Henry's law here. Gas and water will be equally distributed in the closed. When it is open, the carbon dioxide or gas, it may bubble out. So at certain pressure, it is equally distributed. When it is inside the bottle, check ಮಾಡಿದಾಗ it is equally distributed alva, gas and water. So when it is open, liquid settles down and gas come out. That is the Henry's law. Yeah, distribution. Next is the determination of equilibrium constant from distribution coefficient. So distribution law helps in determining the equilibrium constant of a reaction when one of the reactant is soluble in two non-miscible solvent. Distribution law andre no. This is the simple. See, distribution law helps in determining the equilibrium constant, whether the solvents have attained equilibrium or not, that we can be known. So for that, we are going to use distribution law. The equilibrium constant of a reaction when one of the reactant is soluble, when one of the reactant is soluble in two different non-miscible solvents. Two different non-miscible solvents will be taken in a beaker and we are going to add one reactant or a solute that we are going to add to that beaker. So that one, how it reacts with solvent A and solvent B, that can be seen how it is equally distributed between two different solvents, that can be seen here. So the reaction when potassium iodide reacts with iodine to form potassium triiodide. That is the reaction can be carried out in water while iodine is insoluble in both water and benzene. Iodine, when you are going to add into water and benzene, to find the distribution coefficient of iodine, iodine is shaken with water and benzene in a bottle. For example, they are given here iodine, water and benzene ಅಂತ ಇದೆ. ಮೂರ್ ಏನಕ್ಕೆ ಅಂದ್ರೆ ಒಂದು solvent A that will be taken as benzene, solvent B that will be taken as water. ಎರಡು solvent ಆಯ್ತಾ, water and benzene that we are taking in a beaker ಅಲ್ಲಿ ತಗೊಂಡಾಗ two different layers will be formed. The two immiscible solvents ಅಲ್ವಾ. For that we are going to add iodine low concentration iodine add ಮಾಡ್ತೀವಿ. Then we are going to check the concentration of both solvent A and solvent B. Why you are going to check concentration of solvent A and solvent B though? And the concentration of water and benzene ಯಾಕೆ ಚೆಕ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ iodine ಎಷ್ಟು dissolve ಆಗಿದೆ solvent A ಅಲ್ಲಿ ಮತ್ತೆ solvent B ಅಲ್ಲಿ, whether it is equally distributed or not, that we are going to check, that we are going to calculate here. How we are going to calculate andre the concentration of iodine in water and concentration of iodine in benzene, that is K distribution coefficient, that we are going to calculate to know the whether the solvent or whether the solute what we are taken as an iodine is equally distributed or not, we can be identified. That is the distribution law. So this is with respect to for unit 11, that is distribution law. ಇಲ್ಲಿ ಏನೇನು ಇಂಪಾರ್ಟೆಂಟ್ ಅಂದ್ರೆ ಡಿಸೋಸಿಯೇಷನ್, measure of property of large object to separate, association andre the aggressive atoms of molecules into large unit, equilibrium, immiscible distribution, the process in which an observed chemical move away from the site of absorption to other area of the body, how it is distributed between two different solvents. That is with respect to distribution law. Uh, Important question really, Nernst distribution law they may give and Henry's law. These are the two important topics in the distribution law. And next is the physical properties and chemical constituents. So here we are going to study about the properties of liquid. Properties of liquid under viscosity, the flow of liquid on a glass surface, and molecular weight, size of its viscosity, a measurement of viscosity, effect of temperature on surface tension, solute and their surface tension. This we are going to study the physical properties and chemical constituents of liquid. This is only with respect to liquid. So here some of the important topics which you are going to study in this unit under difference between additive property and constitutive property. Law list out the properties of liquid. The properties of liquid you are going to study, and viscosity, temperature of viscosity of a liquid, surface tension, and effect of temperature on surface tension. These are the important topics in this unit. So physical properties andre it is substance depends on intermolecular force which originate in the internal structure or constituents of the molecules. So it is mainly between the molecule structure. So here additive property and constructive property andre additive property is nothing but the total value, the total value of which is the sum of value of its constituent atoms. The total value should be equal to the constituent atom present. For example, here we have taken methane, that is CH4. Number of carbon atoms ಎಷ್ಟಿದೆ? 1 ಇದೆ, hydrogen 4 ಇದೆ. So that we are going to get the molecular mass is 16. Carbon 12 into 1 and hydrogen 4 hydrogens alwa, 1 into 4 hydrogen, that is 16. The molecular weight, the sum of the mass of constant atoms, the total mass of the solution being sum of individual components. So total mass should be equal. That is the additive property. Constitutive property and the molecule constitutive property is one that depends on how its atoms are arranged and final values are not same. So in these constitutive properties, the atoms will be arranged differently and the final value will be different. So it mainly example for those ಅಂದ್ರೆ molecular volume. ಏನ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಅದು ವೇರಿ ಆಗಬೇಕಂದ್ರೆ ಡೈಪೋಲ್ ಮೂವ್ಮೆಂಟ್ ಇರ್ಬೋದು, ಮಾಲಿಕ್ಯುಲರ್ ವಾಲ್ಯೂಮ್, ಮೋಲಾರ್ refraction, optical rotation. So it's depending on the structure of the chemical compounds, whether it is in the ortho, meta, and para position of the chemical constants. So it may vary. For example, they are taken dichlorobenzene here. The value will be 8.3D, 5.7D, and 0D. So depending on the position of its chlorine. So it is in the ortho position, meta position, and para position. Different dichlorobenzene. So the properties of liquid, what are the properties of liquid? And there it will be having defined volume. Volume will be constant and the shape is indefined. Shape can be varied depending on the container or whatever the we are going to store it. So volume will be constant. Volume can be measured. The shape of the volume is indefined. So particle close together, they are closely tightly packed but can move little bit. So liquid can flow and density liquid much greater than gases. So density liquid are greater than gases. Density of the liquid is greater than gases. It weighs more, Allah. So liquid can be compressed, but change in volume is only a small amount required enormous pressure. So liquid can be compressed to gas. ಇದಕ್ಕೇನದು liquid can compress, but change in volume is only a small amount. ಅಂದ್ರೆ ವಾಲ್ಯೂಮ್ ಲಿಕ್ವಿಡ್ ನ ಕಂಪ್ರೆಸ್ ಮಾಡಿದಾಗ ವಾಲ್ಯೂಮ್ ಚೇಂಜಸ್ ವೆರಿ ಲಿಟಲ್. ಸೊ ಇಟ್ ರಿಕ್ವೈರ್ಸ್ ಎನಾರ್ಮಸ್ ಪ್ರೆಷರ್. ಎನಾರ್ಮಸ್ ಪ್ರೆಷರ್ ನ ವಿಲ್ ಬಿ ಕನ್ವರ್ಟಿಂಗ್ into gaseous can be done here. So next is the viscosity. Viscosity andre a liquid is made up of molecular layer that are arranged one on top and another down. So this is the structure of liquid. So there will be different layers of liquid form structure molecules will be present. ಈಗ for example one drop of liquid ಅಂದ್ರೆ different layer of molecules are present in a liquid. So a liquid flows when a shearing force is applied to it. Liquid is not easy to move. ಅದಕ್ಕೆ ಏನಾದ್ರು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಮಾತ್ರ ಲಿಕ್ವಿಡ್ ಇಟ್ ಸ್ಟಾರ್ಟ್ಸ್ ಮೂವಿಂಗ್. The force of friction between the layer, however, it provides residues to this flow. So the viscosity of the molecular layer in constant in which the stationary phase is zero. So if is the force that is inversely proportional to A divided by dV by dx. So here the flow of it takes place under in the figure they are given figure 2. That is the area A and figure area here they will be separated by distance x. And now consider two adjacent moving layers of liquid. There are two different layers of liquid. Liquid layer, two different layers irutte. So this will be separated by distance dx, a velocity difference that is dv. So the force of friction F restricting the relative motion of the two layers is directly proportional to the area. Two layers is directly proportional to the area A and the velocity difference that is dv, while it is inversely proportional to the distance between the two layers. It can be that is friction. The force of friction is inversely proportional to the area divided by dv by dx. So eta that can be written as eta is equal to ಯಾವ್ದು force of friction divided by area into dx by dv. That is the equation 2. So here two layers of the force of resistance per unit area which will be maintain unit velocity difference between a liquid of unit. distance from each other. So it's nothing but ಈಗ one liquid ತಗೊಂಡಿರ್ತೀವಿ, one drop of water. So in that different layers of molecules will be present. So that is just represented in here figure 1 ನಲ್ಲಿ. Molecules ಹೆಂಗೆ layer by layer will be present in the liquid state. So when it should be moved andre there should be external force or some other energy should be applied to move. ಈ layers ನ move ಮಾಡಬೇಕು ಅಂದ್ರೆ what you are going to do? It can not be easily moved from one. So this should be moved andre you should be applying external force that we are going to see here. A force of friction resisting the relative motion of two layers. For example, here two layers ತಗೊಂಡಿದ್ದೀವಿ of one molecule. This is liquid molecule one. So same thing, we'll be having different layers in each molecule of liquid. So there will be force of friction resisting the relative motion of the two layers is directly proportional to the area and the velocity difference between dv. So difference dx is the area between two different layers. Distance, separated distance ಇದು dx ಅಂದ್ರೆ. So this is with respect to liquid. And in the table they are given liquid velocity, viscosity and viscosity in SI units. So CGS units andre that is the centimeter gram seconds. It's with respect to centimeter gram seconds. For benzene it will is 0.00652, carbon tetrachloride 0.09. So CGS units andre centimeter gram seconds. 1 second ಗೆ ಎಷ್ಟು ಸೆಂಟಿಮೀಟರ್ ಮತ್ತೆ ಎಷ್ಟು ಗ್ರಾಮ್ ಮೂವ್ ಆಗುತ್ತೆ, ದಟ್ ಇಸ್ ದ ವಿಸ್ಕಾಸಿಟಿ that we are going to study. So viscosity ಅಂದ್ರೆ ಏನು? It is a measure of fluid resistance to the flow. So it is a measure of fluid resistance to flow. So that is with respect to viscosity. So what are the 0.01? That is given in centimeter gram second. So next is the effect of temperature on viscosity of a liquid. So viscosity is nothing but measure of fluid's resistance to a flow. So what is the resistance it is showing when flow of solvent or liquid? So here the viscosity decreases with increase in temperature. When the temperature of for the liquid is increased, the viscosity will decrease. The variation of viscosity, that is eta with temperature, can be expressed by the following relationship. So eta is equal to A is equal to e to the power of minus e by RT. Eta is the viscosity and A is the area. The area moved. E is the energy and minus e by RT. That is the T is the time. So taking log on both the sides, eta is equal to A plus E by RT. It can be written as ln of eta is equal to E by R into 1 by T plus A. So you can see the plot also here. Log eta is equal to 1 by T. A plot of eta versus 1 by T, a straight line. It has been verified for a variant liquid. It has also been found that there is a 2% decrease in viscosity for every increase in degree of temperature of the liquid. 1 degree temperature increase ಮಾಡಿದ್ರೆ for liquid, there will be a 2% viscosity, 2% decrease in viscosity of a liquid. It is general. 1 degree when you wave increase, 2% of the viscosity will decrease for a liquid. So effect of size on viscosity. What are the size? If the size is varied, what is the how viscosity behaves andre? The size of particle increases, viscosity increases because big particles moves slowly. Big particles, the size of the particle increases, the viscosity increases. Viscosity andre it is a measure of fluid resistance to flow. So what is the resistance it is following? So big molecule andre the it moves very slowly. So viscosity increases because big particles moves slowly. And effect of molecular weight. Next is the effect of molecular weight. Molecular weight increases the viscosity ಏನಾಗುತ್ತೆ increases. So longer the chains, the it's harder to get them into flow. Illo viscosity molecular weight increase adaga the viscosity will also increases. The flow will be less. The resistance for the flow will be very less. So effect of shape with increase in the degree of sphericity of the particle, the apparent viscosity decreases. When it is in the circular, the molecules when it is present in the circular or spherical shape, the viscosity will decrease. Second, the movement of that molecules will be faster, la? So the viscosity will decreases. And next is the effect of intermolecular force. Greater the intermolecular force, greater will be the viscosity. The bond between two compounds when the intermolecular force of attraction is great andaga, greater will be the viscosity. Viscosity great andre the movement of the molecule is slow anta. And measure of viscosity, measurement of viscosity can be written as n eta is equal to pi pr 4 to the power of 4 into T, that is time, divided by 8 LV. So here experiments of pressure, radius, length, and volume offers considerably different. So V is the volume of liquid flowing through capillary and time T, and P is the pressure, and R is the radius of the tube and its length. So how we are going to measure its viscosity of a liquid andre this then outside viscometer. So here the radius of the tube, that is also important, and the flow rate of the liquid, that is the volume which flows to the capillary tube in time, in what time it going to flow, and the pressure rate. P is the pressure what you are going to apply, and R is the radius of the tube. So the radius of tube is also important, and L is the length of the tube. Here experiment measures of P, R, L, and V will be considerably different for instrument. So in Oxford's viscometer, the apparatus commonly used for determination of viscosity of liquid is known as Oxford's viscometer. So viscosity of a liquid, any of the liquid can be measured using Oxford's viscometer. A length of capillary tube joins a pipette to bulb C. This is the bulb C. This is the bulb A and B. So here we are going to add liquid or liquid, and it will be air. So, and we are going to suck it from the A end. That is the afterwards viscometer. Viscometer ಅಲ್ಲಿ we are going to add liquid here. It will settle down. It will settle ಆಗಿದೆಯಲ್ಲ. So that the brown part is the liquid present. And how you are going to measure andre the liquid is sucked up near to the top of the A. Here we are going to suck the liquid until it comes to the B. We are going to suck the liquid and it is released to flow back into the bulb C. That is this is the bulb C. And we are going to measure the time T1 from A to B. So the traveling from A to B, we are going to measure the time taken and noted with stopwatch. Then the apparatus is cleaned and experimental repeated with water. So why you are going to repeat with water also andre keep it as a standard. So taking the about the same volume. Water allo ಅಷ್ಟೇ same volume we are going to take and we are going to suck it from the A end and we are going to measure with A to B. A to B ಎಷ್ಟು calibrated mark ಇಲ್ಲಿ A to B ಇದೆಯಲ್ಲ so mark that we are going to measure from A ಇಂದ B ಗೆ ಎಷ್ಟು ಟೈಮಲ್ಲಿ ಪಾಸ್ ಆಗಿದೆ ಅಂತ. So that with respect to how we are going to sudden it will not be flow ಯಾಕೆಂದ್ರೆ radius of this tube will be very less, the flow rate will be very less depending on the viscosity of the liquid. So first we are going to do it with known or known whatever the solute we are going to take, and next with respect to water we are going to take. Why you are going to do it with water and the keep to keep it as a standard. So knowing the value of the viscosity coefficient of water at the temperature of experiment, the absolute viscosity coefficient of the given liquid can be found. So that is the reason we are going to calculate the water the standard ಗೊತ್ತಿರುತ್ತಲ್ವಾ, with respect to that we are going to calculate the given liquid the viscosity we are going to calculate. So next is the surface tension. Surface tension now we are going to calculate, and the surface tension is caused by pressure of strong intermolecular force of attraction in liquids. So surface tension are generally caused by the presence of strong intermolecular force of attraction in liquid. So intermolecular force of attraction andre between the molecules. This surface tension is present. The force in dynes acting on surface of liquid at right angle to 1 centimeter length of the surface. So you are taken an example dyne. So you can see the surface molecular pulled inwards, and this is molecule which is in the interior molecule. ಈಗ inside the layer ಅಂದ್ರೆ ಸಾಲ್ವೆಂಟ್ ಒಳಗೆ ಇದ್ದಾಗ ಇಂಟೀರಿಯರ್ ಇದ್ದಾಗ it is equally distributed or pulled equally in all the directions. ಈಗ ಒಂದು we have taken two different molecules ಈಗ for example in a beaker. ಇದು upper layer ಅಲ್ಲಿ ಇದೆ ಅಲ್ಲ, if you take this one in the beaker, two molecules are present. ಇದು upper layer ಅಲ್ಲಿ ಇದ್ರೆ the force of molecular reaction where it is moved downwards. The molecule which is present in the lower area, it is equally distributed. That it can be seen here. How the surface energy can be calculated under amount of work done divided by amount of area which is extended. That is with respect to surface tension. Surface tension is caused by presence of strong intermolecular force of attraction in liquid. How it reacts with the liquid. So effects of temperature. On surface tension andre when the temperature is increased, the kinetic energy of the liquid molecule increases, which makes the force between the molecules weaker. When the temperature is increased, the kinetic energy of the liquid molecule increases and makes the force between the molecule force ಇರುತ್ತಲ್ಲ between two different molecules, it will be decreased. It makes the liquid surface have less for pull down inwards. So it makes the temperature increase ಮಾಡಿದಾಗ molecules will not come to the downstream. So it will move upwards. So as the temperature increases, the surface tension decreases. The since surface tension is caused by force of attraction between molecules. The surface tension of it is caused under force of attraction between the molecules. The effect of solute on surface tension. Surface tension depends on the solubility of solute. Solute solubility method it depends. Completely soluble solute increases the surface tension. Partially soluble surface tension will be less. So where the molecules have more attractive intermolecular force. For example, ಈಗ NaCl ತಗೊಂಡ್ರೆ in water it is completely soluble ಅಲ್ಲ. So the surface tension will be more compared to the phenol or soap water. It is partially soluble in water. So the surface tension of soap in water will be less compared to the sodium chloride in water. Sodium chloride in water is more having more surface tension. Why andre? It is completely dissolved in water. That is soap in water andre it is partially dissolved in water alla. The surface tension will be very less compared to the sodium chloride in water. So next is the drop weight or number method. Here when a liquid is allowed to flow very slowly through capillary tube from A to B, ಏನಾಗುತ್ತೆ? A drop will form which will increase up to certain point and then fall. If the radius of the end of the tube be r, this will be the radius r. The total surface tension supporting the drop will be sigma 2 pi r. Drop falls down when its weight W is just equal to the force. Hence, we have sigma 2 pi r is equal to W r milligrams. So apparatus employed in the glass pipette with capillary at lower part. This is called as drop pipette stigmas. So next is the drop weight method. So about 20 drops of given liquid received from drop pipette or weight bottle weight and drop pipette is again cleaned and dried and 20 drops of water is also taken. So why you are taking water on that? To calibrate or to keep the test and standard. Knowing the surface tension of one liquid, the surface tension of other liquid can be found. Surface tension of see is here the knowing the surface tension of one liquid, the knowing the surface tension of one liquid, the surface tension of other liquid can be found. So that's why we standard we are to going to we are be taking water. A drop number method. A liquid whose surface tension is to be measured. It's put into drop pipette to the mark as a Mencius move from A to B. The number of drops is kept tracked if the same way the another one moves from A to B, referred as insius liquid poured into pipette. So here you can take it two different liquid that is N1 and 2 number of drops that form when the same amount of each liquid V is volume is poured. So the volume of drops experimental liquid that is V by N1, V by N1 into dx. D1 is density. So density of that liquids. So that we can calculate we have sigma 1 by sigma 2 V by N1 into D1 by V by N2 into D2. So here density can be determined by density bottle. Once sigma 2 and D2 are known, sigma 1 can be calculated for most of the liquids. And surface tension and chemical constants for sigma 1 by 4 D minus D, that is the C. C is nothing but the constant and sigma is the surface tension, d is the density and vapor of same temperature. So here where sigma is molar volume of liquid, if surface tension sigma is unity, then V is equal to P, where sigma is a mole volume of liquid. If the surface tension sigma is unity, then volume is equal to pressure. The paracar may be defined as molar volume of liquid at temperature at which its surface tension is unity. So paracar andre that is nothing but the empirical constant. So what we are going to take it here in the that is the paracar. Paracar is nothing but empirical constant for a liquid that relates the surface tension to the molecular volume. Use of Pareker in illustrating molecular structure. ಅಂದ್ರೆ illustrating and the molecular structure explain ಮಾಡ್ಬೇಕಾದ್ರೆ use of Pareker, how you are going to uses of Pareker ಅಂದ್ರೆ that is the empirical constant. Pareker ಅಂದ್ರೆ it's an empirical constant for a liquid that relates the surface tension of the molecule. So the paracar is educated in molecular structure. The experimental paracar values of several organic compounds known as molecular structure. So atomic paracar and structural paracar andre there are two different paracars. Atomic paracar andre which are contributed of each of the atom present in the molecules. So number of atoms present in the molecule can be calculated in the molecule. Structural parameter which are contribution of various bonds, rings, and other structure factors present in the molecules. For example, atomic paracar, structural paracar andre we are going to see it in an example. For example, paracar for carbon andre 8.6 ಇದೆ, hydrogen ಗೆ 15.7, paracar of oxygen is 20.7, and nitrogen 12.5, chlorine 55.2. So and also in the same thing paracar for single bond under 0, double bond under 19.9, carbonated bond 0, 3 membered ring ಅಲ್ಲಿ it will be of 12.3, 6 membered ring ಅಲ್ಲಿ 1.4 paracar ಇರುತ್ತೆ. So paracar is nothing but empirical constant for a liquid that relates to the surface tension to the molecular volume. So, for example, atomic paracar and structural paracar, they are given some examples here. This is the structure of benzene. Benzene, either we are going to Kekler's formula. We are going to calculate the total paracar value of this. Andre, there are 6 carbon atoms. Alla, 6 carbon atoms. 6 into 8.6. Carbon ಗೆ ಎಷ್ಟಿದೆ paracar? ಇಲ್ಲಿದೆಯಲ್ಲ ಟ್ಯಾಬ್ಯುಲರ್ ಕಾಲಮ್ ಅಲ್ಲಿ
8.6.
8.6 ಇದೆ. So 6 into 8.6 and 6 also hydrogen. Hydrogen is having the paracar of 15. So that we are going to calculate. And 3, you know, the 3 is the double bonds. 3 double bonds are present in the benzene structure benzene ಅಲ್ಲಿ.
Yes, sir.
So the 3 into 19.9. That we are going to calculate the total paracar of benzene is 206.9. That is the structure of benzene. Structure of benzene the paracar. For example, for atomic paracar. Atomic paracar ಗೆ example ಏನು ಅಂದ್ರೆ structure of benzene where you are going to get 206.9. So next we are going to calculate same method for structural paracar ಗೆ. How we are going to calculate ಅಂದ್ರೆ this is with respect to structure paracar. So it's an structure of quinine ಅಲ್ಲ. So here 6 carbon atoms, 4 hydrogen, 2 moles of oxygen, and 4 double bond. That we are going to get the value of 235. And the same method for structure B, alva, it is having different structure of quinine there. So it may get 216. So the observed value of quinoline is 236. Hence the formula A responds correctly and the structure of its molecule. So here, what is the difference, Andrea? There will be Parakar value will be changed for atomic Parakar versus structural Parakar. The observed value of quinine is 236.8 and the formula A represent correctly the structure of its molecule. So basically you should be knowing what is Parakar, and Parakar is nothing but empirical constant for liquid that relates the surface tension to the molecule or volume. So it is the liquid that relates to the surface tension to the molecular volume. This is with respect to unit 12. This is the end of the unit. And I doubt it, yeah. So with respect to unit 11 ಅಲ್ಲಿ important question ಯಾವ್ದು ಬರುತ್ತೆ ಅಂದ್ರೆ distribution law. Define distribution law ಒಂದು ಬರುತ್ತೆ and explain Nernst distribution law.
Which one, sir?
Distribution law, Nernst distribution law. And their limitations of distribution law. And coming to the unit 12, viscosity and their examples, it may given for 2 marks. And Ostward viscometer ಅಂತ ಇದೆ ನೋಡಿ experiment. Measurement of viscosity and Ostward viscometer. ಅದೊಂದು ಆಮೇಲೆ surface tension, effect of temperature on surface tension. And next is the Parakar, uses of Parakar in illustrating the molecular structure. From these 2 units ಇಷ್ಟು ನೋಡ್ಕೊಳ್ಳಿ. ಡೌಟ್ ಇದೆಯಾ? ಅಂಡ್ ಮೋರ್ ಓವರ್ ಯಾವುದೇ ಯೂನಿಟ್ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ತಿಲ್ಲ ಅಂದ್ರೆ ಯು ಗೋ ಥ್ರೂ ದ ಸಮ್ಮರಿ. ಆ ಯೂನಿಟ್ ಎಂಡ್ ಅಲ್ಲಿ ಸಮ್ಮರಿ ಆಫ್ ದ ಯೂನಿಟ್ ಅಂತ ಇರುತ್ತಲ್ಲ, ಹೋಲ್ ವಿತ್ ಇನ್ ದ ಪ್ಯಾರಾ ಯು ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಹೋಲ್ ಯೂನಿಟ್ ಏನಿದೆ, ಕಾನ್ಸೆಪ್ಟ್ ಏನು, ಎವ್ರಿಥಿಂಗ್ ಗಿವನ್ ಇನ್ ಡೀಟೇಲ್. ಆ ಯೂನಿಟ್ ಹೋಲ್ ಕಾನ್ಸೆಪ್ಟ್ ವಾಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಸ್ಟಡಿಡ್, ಏನು ಓದ್ತಾ ಇದ್ದೀರಾ ಅನ್ನೋದು ಸಮ್ಮರಿ ವಿತ್ ಇನ್ ಅ ಪ್ಯಾರಾ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್.
Okay, sir.
ವಿತಿನ್ ಅ ಶಾರ್ಟ್ ಟೈಮಲ್ಲಿ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ಬೇಕು ಅಂದ್ರೆ ಯು ಶುಡ್ ಗೋ ಥ್ರೂ ಸಮ್ಮರಿ. ದ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ ಅದರಲ್ಲಿ.